Greetings to my beloved Dr. Najla Naziha binti Masood, and my fellow friends. My name is Yuvanisha Anlaki Subramaniam, and I'm from Section 7, currently taking Manufacturing Process course. And today, I would like to present about my polymer assignment on the topic of thermoset and thermoplastic. Okay, let us look at what is thermoset. Thermoset, which is also can be known as thermosetting polymer, is initially in a liquid state, and when it is heated, energy is supplied for the chemical reaction that enhances the cross-linking between the polymer chains. This eventually causes the thermosetting plastic to become irreversibly rigid. Second, these crosslinks tend to hold the particles in a particular position where it prevents the material from melting. Thermoset plastics also known to reach a special form where it does not transform into fluid state even when it is overheated. Thermoset plastics are normally used in an environment where heat and chemical are involved. This is because thermoset plastics have a special and greater structural integrity where it can sustain excessive heat and chemicals. It also has higher resistance towards deformation. This is the example of the cross-linking of thermosetting polymer. Next, I would like to move on to the advantages and disadvantages of thermoset. What are the advantages of thermoset? It has strong dimensional stability, low thermal conductivity, water resistant, corrosion resistant, high heat resistance, cheap, flexible, electrical insulator, and there are also disadvantages of thermosets, such as non-recyclable and disability to be reshaped. Now, thermoset undergoes three main processes in order to provide a great product. Number one would be compression molding. What is compression molding? For this process, it will be located in a preheated mold cavity where the mold is then eventually closed and compressed with the aid of a hydraulic press. Hence, this will form the plastic and also the inner contours of the mold. The heating process enables the enhancement of the material flow by initiating the chemical bonding process. This is the illustration of compression molding process. Stage 1 is heating of the mold, and stage 2 will be preheating of the laminate without applying any load. For instance, stacking was put inside an upper platen was closed quickly, and stage 3 will be consolidation of polymer under loading, and the final stage will be cooling and forming of the laminate under loading. Now, I will move on to the second process, which is transfer molding. This process is responsible for the creation of new product by filling the mold cavity with the raw material. Initially, the raw material should be placed in a transfer pot which is specifically on top of the upper mold half. Then, the mold will be compressed to seal and followed by a transfer ram forcing the material from the transfer pot into the mold cavity. The polymer is then displaced when the force is increased on the transfer ram. The inner contours will be displayed as well. In most of the case, during this transfer molding process, the transfer pot itself is heated where it helps the chemical bonding to take place. This is the example of illustration of transfer molding process. Now, I'll move on to the final process, which is injection molding. The principle of injection molding is that the plastic material will be heated until the plastic resin is liquefied and becomes a viscous metal. Not only that, the polymer is heated and injected into the mold using a screw. Thus, when the polymer is melted, the displacement into the mold cavity is simplified due to the low viscosity. A stuffer plays an important role in this process where it is used to oppose the gravity fed hopper because the thermoset compound are not free flowing. The stuffer also acts as a feeder where it feeds material into the screw within the injection barrel at a constant rate. And this is the example of illustration of injection molding. Number one, the plastic granules fed via hopper, which is the funnel, into barrel and heated into a molten state. Number two, heated plastic fills barrel. Motorized screw pushes molten plastic to mold. Number three, screw injects molten plastic at pressure into mold cavity via gates and hot runners. The plastic product is also allowed to cool and solidify before being ejected from the opened mold. There are a few examples of commonly used thermosetting resins such as epoxy, polyester, phenolic, silicone, polyurethane, and polyamide. This is the example of silicone, and this is the coating of epoxy which is used on the floor, and this is polyester, and this is polyamide, which is a nylon. Now, I would move on to thermoplastic. Thermoplastic, where polymerization process takes place, causes the monomers to join together and form long chains that eventually creates thermoplastic. The atoms in a polymer chain, which is made up of thousands of monomers, contains a very strong covalent bond. Despite that, thermoplastic can be classed as a polymer that can be softened through heating. Besides that, thermoplastics gets hardened once it is cooled. This does not change the chemical property even though it is heated for several times. Sorry for the spelling error. Now I will move on to the advantages and disadvantages of thermoplastic. There are few advantages of thermoplastic products such as easily recyclable, lightweight, high chemical resistance, large range of mechanical properties, energy efficient, corrosion resistant, high impact resistance, and electrical insulator. Whereas on the other part, the disadvantages are it is expensive, not suitable for high temperature applications due to low melting point, and it is susceptible to creep if exposed for long-term stress loads, which is known as also easily brittle. Now, thermoplastic also undergoes three main processes. Number one is extrusion. During this process, materials undergo plastic deformation because the materials will be forced to flow through an orifice or die. The cross-sectional profile of the die will be adapted by the material. So, when the material has the right properties, the shape will be maintained during the final extrudate. The force required is actually produced by a moving piston or a rotating barrel. Finally, the extrudate will be cut into pieces to form a discrete parts. Hence, this is the simple illustration of extrusion process. Now, I will move on to the second process, which is thermoforming. Initially, the thermoplastic sheet will be heated until it reaches its softening point. The sheet then will be changed and stretched across a single-sided mold before it is cooled down to its required shape. The sheet has to go through vacuum forming, pressure forming, and mechanical forming, which is three types of forming, in order to retain its desired shape. Moreover, the benefits of thermoforming are efficient, cost-effective, and short lead time. These both are the illustrations of thermoforming process. And the final process of thermoplastic will be blow molding. This process is used to form a hollow object by blowing a thermoplastic molten, which also can be known as parison. The blown thermoplastic molten will take the shape of the mold cavity. Then, gas at a certain pressure will be released into the parison in order to blow the heated parison against the cavity walls. Hence, the product is formed. This is illustration of the blow molding process. First, heated plastic is extruded into hollow tube, which is the parison. Mold closes, parison is gripped in place. The third one, compressed air blown into parison which inflates. and then the partition is filled with the mold. And number 5, product is trimmed and removed from mold, finished product ready for the next production stage. And finally, I would like to explain about the several examples of thermoplastic products such as polyethylene, polypropylene, polycarbonate, polyvinyl chloride, and polystyrene. This, as we know, it is used in our daily life. It is the PVC plastic. This is also used in our daily life. It is polystyrene. This is polycarbonate, and this is polyethylene. And this will be my references. And that's it for my presentation. Thank you very much.